Solutions for today's worksheet, where we got kind of an introduction to logarithms. So in these first two sections, really the idea here is to get you comfortable switching between exponential form and logarithmic form. So for now, all you need to know is that the log base a of some number b equals c is equivalent to a to the c power equals b. Kind of shuffling the letters around for some reason that you may or may not understand at this point. Just got to be able to do it. So this is the same as saying that the log base 4 of 64 would be equal to the number 3. Just switching around these three numbers similar to this outline right here. Similarly, this tells you that the log base 16 of the number 4 is, for some reason, equal to 1/2. And up here, you could say that the log base 1/7, which is rare, usually don't see fractional bases like this, but it's possible, I guess, of the number 1/49 is equal to 2. And then this one over here is telling you that the log base 3 of 1/81 is equal to -4. And that's it. In this first section, just shuffling them around, being able to go from exponential notation to logarithmic notation. Why would you ever want to be able to do that? Well, when we get more comfortable with logs later on, we'll be able to solve things with logs, and sometimes there'll be a preferred form to be in. Now you can imagine a case where this 3 up here is an x. You're trying to solve an equation and get the x all by itself. Well, if 3 ends up over here, if this were an x, you'd have an x all by itself. If you were trying to isolate x, it might help to have it in this form. But that's beyond where we are right now. For now, just do the shuffling. Same idea here. If someone tells you that the log base 4 of 1/16 is equal to -2, in exponential form, that's just saying that 4 raised up to the -2 power is 1/16, which is true, which is 4 to the -2 power is the same as 1/4 squared. And 4 squared is 16. But these are both true statements. It's just different ways of writing it. This is in logarithmic form. This is in exponential form. The log base 1728, okay, of 12 equals 1/3. What that tells you is 1728 to the 1/3 power is equal to 12. Or if you prefer, the cubed root of 1728 is equal to 12. Whichever one you like. Raising something to the 1/3 power is the same as taking the cube root of it. Log base 5 of 125 equals 3. That's just saying 5 cubed is 125. Log base 6 of 1 equals 0. That's just saying 6 to the 0 power equals 1. Log base u of 1/16 equals v. Okay, it might seem more complicated. You got letters floating around, but it's really not. It's the same thing. It's just now u raised up to the v power is 1/16. And similarly here, it would be 4 raised up to the u power is equal to v. And finally down here, we'd have y squared is equal to x, and we'd have 5/2 raised up to the y power is equal to x. And that's it. Just kind of shuffling things around. It'll benefit you to be comfortable going back and forth between these two forms, because when we learn more stuff, both forms will have its advantages, and you'll want to be able to immediately switch from this to this without thinking twice about it. Second page. The second page gets more into what this means. So when you are asked what is the log of 1,000, yeah, you could figure this out. You could say log of 1,000 equals x, and then convert it into exponential notation, kind of like we did up here, and try to talk yourself into it. But really, I think it's good to just understand what this question is asking you. And what this question is asking you is 10, the 10 that's kind of implied right here, raised up to what power equals 1,000? And so the answer is 3, and that's because 10 to the 3rd power is 1,000. So because 10 to the 3rd power, I need to drink some water, is 1,000, the log base 10 of 1,000 equals 3. Similarly, over here, this is asking you the question, to what power must you raise 2 to make it equal to 1/64? Well, that was a little bit tricky. Wait, 2 to some power is equal to 1/64? Well, 2 to the 6th power is equal to 64, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. But I don't want 64, I want 1 over 64. You might recall that negative exponents mean take the reciprocal of. Maybe I'll even write, this one's true because 10 to the 3rd power is 1,000. This one is true because 2 to the negative 6th power is just 1 over 2 to the 6th power, which is 1 over 64. That's why those are true. You don't need to put that in there, just a little backup for you. Log base 1/4 of 4. That's asking you to what power must you raise 1/4 to change it into a 4? And the answer to that is -1, and the logic there is 1/4 to the -1 power is equal to 1 over 1/4, which is equal to 4. And finally, the log base 216 of 6, I think that'll end up being 1/3, and my logic is that 216 raised up to the 1/3 power is the same as the cubed root of 216, and the cubed root of 216 is 6, because 6 times 6 times 6 equals 216. These are the answers. There's a little logic behind them. Finally, the challenge questions. These are on there because I was afraid people would finish this earlier stuff too quickly, and I wanted to keep you busy. Maybe I shouldn't admit that. For the challenge questions, this first one, I think these all come from this first one. If you can get this first one, if you can't get this first one, the remaining 4 will be virtually impossible. If you can get this first one, you have a fighting chance for the rest. 4 raised up to the log base 4 of 9. That's a hard question. But if you think about what the log base 4 of 9 is, the log base 4 of 9 is the power. So this whole thing is an exponent. It's the exponent that 4 needs to be raised to make it a 9. So if I take a 4, this 4 right here, and I raise it to this special exponent, which is the power that a 4 must be raised to make it equal to 9, this is just going to equal 9. I'm taking 4, and I'm raising 4 to the power that 4 needs to be raised to change it into a 9. Kind of sounds weird, but if you say that enough times, maybe you can talk yourself into this being equal to 9. If that really bothers you, I'm going to erase this in a minute, but note that 2 raised up to the log base 2 of, 16. The log base 2 of 16, if you just look at the exponent, this is the power that 2 needs to be raised to make it a 16. So this is the number 4. And so you could write that this is 2 to the 4th power, but 2 to the 4th power is just 16. In fact, you don't even need to know that this is 4 to figure out that this is 16. I knew this was going to be 16 way back here, because this exponent is the exponent that 2 needs to be raised to make it a 16. So if I raise 2 to that exponent, I get 16. Similarly, even though I don't know the log base 4 of 9, it's some fraction, some decimal between 1 and 2. I know that it's the perfect decimal that when it's used as the exponent on 4 will change it into a 9. If you have that knowledge, I think you can do the rest of these, although they're a little bit tricky. This first one, I have a log rule that says anytime you have a fraction, a quotient raised up to an exponent, you can take that exponent and distribute it in some sense to the numerator and the denominator. This might look weird, but think 1/2 to the 3rd power. That's just 1 to the 3rd power over 2 to the 3rd power. Well, same idea here. So what is 1 raised up to the log base 4 of 9? Well, 1 raised up to any power, except for 0, is equal to 1. What about 4 to the log base 4 of 9? I just figured that out. That's 9. I did that over here. It's just 9. This answer's got to be 1/9 right here. What about this one? Well, if it were 4 raised up to the log base 4 of 9, it would be easy. It would just be 9. If it were 2 raised up to the log base 2 of 9, it would be easy. It would just be 9. But it's not. We have these nice little tricks that work whenever this base is the same as this base. And it's this trick right here that we'll make more concrete in the next section. So what am I going to do if this base isn't the same as this base? Make them the same. 2 is the square root of 4. So instead of writing 2, I can say 4 to the 1/2 power. Why? How does that help you? Well, when I have an exponent raised up to an exponent, I have a rule that says I can just multiply together those exponents. So I have 1/2 times the log base 4 of 9. And so I can use this rule again, except for in reverse, to say that this is equal to 4 to the log base 4 of 9, all raised up to the 1/2 power. If that last line gave you trouble, pretend you started right here. You got an exponent to an exponent, so you multiply those two things together, and you get right here. So if this is the same as this has got to be the same as this. Note that inside the parentheses, what I have is question 1. So really, this whole thing inside the parentheses is just a 9. What this question is asking me is what's 9 to the 1/2 power? Well, 9 to the 1/2 power is the square root of 9, and that's 3. Similarly, over here, very similar. These problems are almost the same. The only difference is instead of saying it's 4 to the 1/2 power, I can say that 16 is 4 to the 2nd power. And so I can say that is 4 raised up to 2 times log base 4 of 9, which I can say is 4 raised up to the log base 4 of 9 squared. And I know from part 1 that 4 to the log base 4 of 9 is just 9, so this is 9 squared, which is 81. Finally, down here, number 5, I have a log or an exponent rule that says when you're multiplying together two exponents and they have the same base, you can just add up those two exponents. This is an exponent rule. X squared times x to the 3rd power is x to the 5th power, because 2 plus 3 is 5. I can apply that here kind of in reverse. What I have is this base 4 raised up to the sum of two things. So I can rewrite this as 4 to the 1 power times 4 to the log base 4 of 9. If you have trouble going from here to here, talk yourself through it backwards. If you start out here, so I have the same base, so I add up the exponents. 1 plus log base 4 of 9, which is exactly this right here. 4 to the 1 power is 4. 4 to the log base 4 of 9 power is just 9. 9 times 4 is 36, which is the answer to this question. That ends this worksheet, so I'll stop the video here.